Welcome to this video on rate of change. By the end of this video, you should be able to describe the rate of change between 2 points by looking at 2 points on a graph, by calculating it between 2 points from a table, calculating rate of change between 2 points on an equation, or from a word problems, and you can interpret rate of change. Alright, so rate of change is really just slope. Okay? So it's your rise over your run, your changes in y's divided by your changes in x, and that's where this formula comes in right over here. The changes in y's come from y minus y, and the changes in x becomes x minus x. Okay, a function's rate of change can be constant, meaning it's the same every single time, or it can be variable, which means it can be different every single time. If a function is linear, meaning the graph is a line, then the rate of change is always constant. It's the same every time you count it. But if the function is curved in any way, shape, or form, the rate of change can be variable. It's going to depend on which 2 points I ask for, and the rate of change will be different each time. So if we're on a graph, we can just count between the 2 points on the given interval. So if our rate of change is positive, or our slope is positive, that means that the graph is increasing or going up as it goes left to right. And if I have a negative slope or a negative rate of change, that means my graph is decreasing or going down left to right. All right, so let's just take a look at a few graphs here and get our rate of change. So rate of change is the distance, like how does the slope change between 2 points. I have 2 points marked on here. So what I want to do is, how do I get from the left point to the right point? Because we always read left to right. I know if I want to get there, I'd have to go up and across. So I want to know, how far up do I go? Starting from here, 1, 2, 3. I went up 3 from the corner. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm counting my steps, my rise over my run. My rise is 3 and my run is 9. So my slope, if I reduce my fraction, is 1/3. And if we check, we can check it. Here's where I started. If I went up 1 and right 3, there's my point. Up 1, right 3. Up 1, right 3. I keep hitting the line by going up 1 and right 3. That's my constant rate of change. Okay. My next graph is also a line. Remember, we always read left to right, so we want to start with the left-hand point first. How do I get to the right-hand point? So I have to go down 1, 2, 3, 4, 5, 6. I went down 6, so my rise is -6. And then I went right 2, which is a positive number. So my slope here is -3. Okay, so those are lines. If I count down 1, 2, 3, and right 1, I'm on the graph. Same exact slope, 1, 2, 3, right 1, I'm on the line. Constant rate of change. But when we have curves, we could have different amounts. So now this is written differently. This is written a lot like how we would write domain. What it's saying is, I need the point where the x value is -3. So I find where x is -3, and I either go up or down to hit the graph. This graph actually just happens to go through. That's one of the zeros there. So there's my point. The other point is where x is 2. So to be on the graph, I'm going to have to go down. So I want to know, how do I get from the left point to the right point? How far down and how far across do I go? So I had to go down 5, and then I had to go right 5. So my rise was -5 and my run was +5, which gave me a slope or rate of change of -1. What it's really asking for is the slope of the line that will connect those 2 points. From here, if I go down 1, right 1, down 1, right 1, down 1, right 1, there's my slope. Okay, so even though it's variable, and we said lines are constant, here's why. If I asked for 2 different points, so let me use a different color. If I wanted to know this point and this point. They're really close together. I'm really asking for the slope of the line that goes between them, which is up 1, right 1. Well, the slope on this guy is actually a positive one, not a negative one. It has a different slope. It would depend on which 2 points I'm asking for. So you always have to read what you're being asked for. All right, let's try it on our exponential function here. It says when x is 0, to be on the graph when x is 0, I want to be right there. And when x is 2, to be on the graph, there's my point. So how do I get from the left point to the right point? I've got to go up this far and then right that far. So I'm going to go up 1, 2, 3 and run 2. So my slope here is 3 divided by 2. All right. Let's flip this over and try some of the problems on the back. All right, now we're going to find our slope from a table of values. When you have a vertical table of values like this, the column on the left is your x values, and the column on the right is your y values, just so you know. And this says we want to find the rate of change of temperature. So how did the temperature change between 2 and 9 hours? So if my x value is 2, if I look at my table, that says my y value is 4. So I have 1 point. If my x value is 9, check the table. That says my y value is 25. Okay, so we're going to use our formula here. y2 minus y1 divided by x2 minus x1. Really, the order in which you subtract does not matter. You just need to always start from the same point. So I'll show you an example. I'm going to say 25 y minus y. Now, because I used the 25, I have to start in that same point when I subtract on for the x's. 9 minus 2. 25 minus 4 is 21. 9 minus 2 is 7. That's going to give us a rate of change of a positive 3. All right, let's try this again. I'm asking in a slightly different way. These are still x values. So if my x value is 5, when I look at my table of values, I see that 5 has a y value of 13. And if my x value is 11, I see that my y value is 31. All right, so this time, last time I started in the bottom and subtracted the top. It doesn't matter. This time I'm going to subtract 13 minus 31, y minus y, divided by, but because I started in this point with 13, I got to start with a 5 on the bottom. 5 minus 11. 13 minus 31 is negative 18. 5 minus 11 is negative 6, giving us a slope of 3. Both of these are the same number. That means our slope is constant, our rate of change is constant, and it's a positive number. So that means we're increasing as we go from left to right. So this would be a line if we graphed them all out and graphed out all these points. It'd be a line because it has a constant rate of change. All right, let's check out number 6 here. I give you an equation. It says y equals. Well, what that means is if you plug in x, you'll find out what y is. Okay, so if we plug in 0, you'll get out 6. Because 2 times 0 is 0, plus 6 will be 6. If we plug in 1, 2 times 1 is 2, plus 6 is 8. If we plug in 2, 2 times 2 is 4, plus 6 is 10. So hopefully you're starting to see a pattern here. 6, 8, 10. If you plug these numbers in, here's what you're going to get. Okay, but when I look at the equation, this is the equation of a line. Its highest exponent is 1, which makes it linear. This says it has a slope of 2. That means the slope is 2. If we look at our y values are increasing by 2, and our x values are increasing by 1, which gives us a rise of 2 and a run of 1 for a slope of 2. I'm going to prove it to you again. If x is 1, my y value is 8. And if x is 2, my y value is 10. Y minus y divided by x minus x equals 2 divided by 1, which is 2. Okay, So that's the linear equations. Looking at the table, it says 2. We proved that this point was 2. This point should also be 2. This is not actually a point. These are two different x values. See the square brackets? That's your hint that this is not a coordinate point. This is saying if x is 3, what's your y value, which is 12? And if x is 4, what's your y value, which is 14? And we have y minus y divided by x minus x equals 2 divided by 1, which is 2. Further proof that this is indeed a line, so it's constant, it's a positive number, so it's increasing. All right, we're going to do a very similar thing, but just without the table of values for the next two. I have an equation just like I had previously, and I tell you the two x values. So if x is -1, I want to know what the y value is. So we can take -4, where the x is, I'm going to plug in -1 plus 10. -4 times -1 is 4 plus 10 gives us a y value of 14. If I plug in 3, so I have -4 times 3 plus 10. Well, -4 times 3 is -12, plus 10 is -2. So those are my 2 points. I'm going to say y minus y, so -2 minus 14, divided by x minus x. Well, that minus the other x is negative, so you got to remember to have a double negative there. -2 minus 14 is -16. 3 minus -1, this is going to turn positive, equals 4, and -16 divided by 4 is -4. This graph is a line because the highest exponent is 1. So it's decreasing and it would have a constant slope. We could put two different x values from what we just did and we'd still have an answer of -4. All right, number 8. This is not linear, this is squared. That makes it a quadratic. So it does not have a constant rate of change. But the same idea, I have a 2 for an x value and a 4 for an x value. I have to find their y values. So if I plug 2 in, so we can use our calculator for that, but 2 squared is 4, times 2 is 8, minus 3 is 5. So if your x is 2, your y is 5. If your x is 4, we're going to get 4 squared is 16, times 2 is 32, minus 3 is 29. You can use your calculator to get those points too. There's my 2 points, and I'm going to say y minus y divided by x minus x. So I get 24 divided by 2, which gives me a rate of change of 12. We know it's not constant because this is quadratic, so it'd be variable, but it is increasing between those 2 points because our slope there is positive. All right, 2 last ones. They're word problems, everybody's favorite. So we have traveled for 3,000 miles in 40 hours. So 40 is really your x value. Your distance is your y value. Find your rate of speed. Well, we need a second point. And it doesn't tell us the second point, but if we haven't left yet at 0 time, we will have gone 0 distance. So I'm going to say y minus y divided by x minus x gives us 3,000 divided by 40, which gives us, when we use our calculator, 75, and that's miles per hour. If you read the problem, that's our context there. And now our last one. You have been working at McDonald's for 2 years. Your starting salary was $6.25 per hour, and now you're making $6.49 per hour. Find the rate of change of your salary. So how did your salary change over time? When you were first hired, so before you began working, you were making $6.25 per hour. But now you've been there for 2 years, and you are making $6.49 per hour. So we have 2 points. So I'm going to say y minus y divided by x minus x. 649 minus 625 equals 20.24. 2 minus 0 is 2, which gives us a change of 12 cents per hour. That's how much of a raise you've gotten over the course of those 2 years. Hopefully that was helpful. Let me know if you have any questions. See you in class.